How would we classify a triangle based on its sides? Like, can you think of a name that you would call a triangle based on its sides? Scarlett? Isosceles. Okay, do you remember the definition of isosceles? How many sides are equal in an isosceles? Ben? 2. So isosceles has 2 equal sides. Now they will dive more into isosceles, I believe, tomorrow in the next couple lessons. Because if you did not know this, and here's one of your answers for the next category. An isosceles right triangle is the strongest triangle there is. So if you look at the rafters of your house, or if they're building something, like if they're building a house or whatever, or if you go up into your attic or your garage if it's unfinished, those are all isosceles right triangles because they can bear the most amount of weight. If you've ever tried to shingle something, has anyone ever shingled a roof of any type? I was extremely surprised when my dad and my husband built a shed and they asked me to carry the pack of shingles from the truck to where they were working. I thought, no big deal. Holy moly, 1 pack of shingles is 80 pounds. Try carrying 80 pounds like on your arms. It is amazing how heavy those actually are. So the rafters of your house, they've got to be extremely strong, and it's a good angle for snow. If you go to other parts of the countries, you don't see pitches of roofs like ours, like in the Midwest or in the North. My husband's from California. Their roofs do not look like ours because they don't have to worry about the snow sliding down. Okay? So, again, there's some architecture, there's some reason behind some of the style of our houses and things like that. But isosceles, you're going to hear more about. All right, give me another type. Ben? Scalene, sorry. Took my brain a second there. Scalene. Do you guys know what scalene is? Michael? Yeah, so no equal sides. So all 3 are different. So we have none. We have 2. Do you remember what it's called when you get 3 equal? Equilateral. So those are your 3 vocabulary words based on sides. Then angles, I already gave you one of them, and that's right. So you can have a right triangle. And hopefully you know that if it's right, that's only one 90-degree angle. Give you another one. So if you're looking at a triangle at the angles, what else could it be? Acute. And that's when all are less than 90. I guess technically it's between 0 and 90 because you're not going to have a negative, but I think you know that. Obtuse. Now be careful with obtuse. Maybe you don't, but I feel like in my years of teaching, I've had kids think that they all have to be obtuse. To be obtuse, you only need one angle over 90. It doesn't even have to be into the hundreds. 95 degrees is obtuse. So it's one angle over 90. That's obtuse. Then the last one goes off this one. 3 equal sides, 3 equal angles. Do you know what it's called? It's very similar. Equiangular. So all 3 angles are congruent. Now, there is another little piece off this one. I don't know why they didn't do it in this lesson. All I can tell you is it's in tomorrow's lesson, but your brain might already be going that way. If you are equiangular, how much is each angle? 60. You have to be the same, which would be 60. So for whatever reason, they put that in tomorrow's lesson, but you might be kind of already thinking that, so yes, it is true. But they just, again, don't ask you on it today. All right, on 1 through 4, they just want you to classify using one from each category. So you have to give 2 different words. So how about number 1 here? How about Avery? What would you classify number 1 on? How about with the sides? Yep. And how about Haley? What would you classify it with angles?
Acute.
Okay, be careful. I do agree these are acute. I like that. But they're all the exact same.
Okay, then, yeah, that one.
Yep, equiangular. If you say it's acute, it's kind of like linear pair. Linear pair angles are adjacent, but we also are on a straight line, so then it's better to say linear pair. So it's kind of like which is the best. How about 2? Aubrey?
Do you want both or just the sides?
You can give me both.
For the sides, we'll do isosceles.
Yep. And then what about the angle?
Would that be acute?
Okay, look right here. Do you see this?
Oh, so right.
So it'd be right. That, again, is the strongest triangle out there. You see it a lot in construction. Okay, how about number 3? Sam, what are you thinking on 3?
Scaling.
Okay, look right here at the 2.5 and the 2.5.
Oh, I was on 4.
Oh, sorry. Okay, we can do 4. 4, he said, is scalene.
Yeah.
Now, since he did 4, let's finish 4. Angle-wise. This is actually in the real student journal. Like, there still is a student journal. Hudsonville just didn't buy them because they figured it was more to buy the student journals than it was to just us copy them off, you know, the cost. So this is in the student journal, and I looked to see what they put for the angle, and they wrote acute. Now, I definitely would agree that this probably looks acute, but they say the human eye cannot detect between a 5 to 10 degree difference. That if somebody draws you, you know, an angle that's 85 versus 92. 85 is acute, 92 is obtuse. They say with the human eye that your eye would not be able to detect that small. Now, if somebody draws you a 20 and 100, you're going to be able to tell the difference. But within that 5 to 10 range, they say our eye really cannot detect it. So how do you not know that this might not be like 91, 92 degrees? You know it's not 90 because it's not marked. So if I was, like if this was on a quiz or test, I would accept either acute or obtuse because I really don't know exactly what this angle is right there. It's what?
You can just flip it. Like, so one of the sides with the 1 mark on it is the bottom.
Yeah. And then
So you just like turn your
so you
paper.
turn it so that it looks flat, and then if it goes straight up, then it's 90.
So then if it's like this,
Yeah, so
That's
that
it.
would be 90, and then if it went in,
like you say, I'm just saying that I feel like on ones like this where they're kind of borderline, I think I would probably give you both, okay? All right, how do you guys feel then 3? We kind of skipped that one over. Christian, what are you thinking on 3?
I thought it was isosceles,
All right,
non-obtuse.
obtuse?
Yeah.
Yep, because of the 120, I had to look real quick. Obtuse. So do you guys feel okay with the vocabulary? All right, number 5 is the same vocabulary. Do you see how it still says classify? Only this time, you don't necessarily know what it looks like, so you might just have to graph it. I guess if you don't need to graph it, then that would be okay, but it might be hard to tell where it's at. So let me quick graph it. Now, they're just asking you to classify. But you know, ladies, like this last test was only out of 30. We're supposed to have a quiz. I'm going to look more at the calendar this weekend. But let's say we have a quiz next week, and let's say it's only out of like 20. You're not going to want to just make a quick assumption, and then what if you get it wrong? And out of 20, only 2 wrong is going to put you down to an A minus B plus. So you're going to want to be for sure. So how do you think, what are some ways we could be for sure of what this is? Because there's multiple right answers too. Sadie?
You can measure the side length.
So how would I measure the side lengths? Like this one I can count. From here to here is 6. I can count that. Negative, positive, that's 6. How would I know this side though? Well, I could count, but it's like not solid boxes. Like I don't know if it's exactly halves.
Okay. I did like
Hold on.
find the slope and go like right and then up from like point A. You know what I mean?
Which way did you go slope, to B or to C?
But I went to B and then I went to C to find if they had the same slope.
Okay, so the slope is basically of AB. The slope is 1. And then on this one, the slope of AC is -1. What does that tell me? They're perpendicular, which means it's a right angle. So that gives me the angle part. That gives me this angle description. But how am I going to do the sides?
Because it's a right angle, that means that 2 sides are going to be like perpendicular, and since it's a triangle, that means that those 2 sides are the same length.
Well, I agree with part of your statement. If you have perpendicular, that does mean 90. But this could be 6 and this could be 8. By Pythagorean's theorem, a squared, b squared, they don't have to be the same. They can be. I'm not saying that they couldn't both be the same number. But by Pythagorean's theorem, they don't have to be the same. I'm not saying this one is not the same. I'm just saying we don't want to make an assumption. Man, nobody has suggested anything from last chapter.
Just use distance.
I could use distance, that's not from last chapter, but yes, I could go over here and I could calculate AC, and I could calculate AB, yes? I'm not saying I'm lazy, but I kind of don't want to do distance formula. Nobody would use the line of reflection in the last chapter? So, if you use the line of reflection, you'll notice that these are the same length. So what I'm telling you is you don't have to show your work here. Like you don't have to do the distance formula. You can if you want. But you need to kind of have something to back up why you're saying what you're saying, because if you just make a random guess and you get that wrong, again, when something is only out of, say, 20 points, that can bring your grade down quite quickly. So this is an isosceles right triangle. If you do the distance formula, it does work. I forget the exact number, but it does come out to be the same. Okay? So, how do you guys feel with classifying? You feel comfortable? Yes? Okay. On the back. I told you that there are proofs coming up, and these theorems, so you see 2 new theorems here, these 2 theorems are not really used in the proofs. The top theorem is used in some proofs, it's just not in our chapter 5. Like, I don't know exactly what chapter. I know we only go up to 6 in this class, but let's say in Geometry B and stuff like that. You will use this in other proofs, so it's important to start to learn it. But triangle sum theorem just tells you that the three angles total 180. So if you have to find a missing angle, you just subtract from 180 and you've got it, okay? Now, exterior angle, I have never used in a proof that I can think of. Now, granted, maybe I shouldn't say never because I'm 42, so maybe I have at one point. But exterior angle really is just helping you calculate the answer. So take a look at number 6. I realize you could use triangle sum theorem. Just watch mine, please. I could take 180 and I could subtract off the two angles I know. And I could write down that this is 74. And then I could use linear pair to get the outside angle, correct? So I have my outside angle and so I'm done. No big deal. That wasn't too hard. But if you want to start to go a little faster and skip some steps, the exterior angle theorem tells you that the angle on the outside is equal to these two together. So take a look at my calculator again. If I would have just added 53 and 53, I get the right answer. Now, they don't have to be the same. So let me just draw a random triangle here. How about we'll go 80 and 30. 80 plus 30 is 110, correct? Which means this would have been 70. Which means if I do linear pair, this is 110. So what they're saying to you is this is just a little faster way. The real area where you need it is when you hit one like number 7. Take a look at 7. If you don't like the exterior angle theorem, you're going to be stuck. Because, do you see this? You can't use triangle sum theorem to find this missing angle and then use linear pair, can you? Now, you could probably still get the right answer. It's just going to take a lot more work. So if you use exterior angle theorem, all you have to do is add 70 plus x. So 70 plus x. And then you're going to set it equal to the outside. The first 3 lessons of this chapter are a lot like this, where I would call it mini equations, maybe 1, 2-steppers. You just have to know how to get them set up, and then it's just a quick solving. So if I move the 5, and if I move the x, now be careful because that's not the answer. That's the answer for the x. They want you to give this angle. Now you can get it one of 2 ways. You can either plug 75 in right here and work this out. So 2 times 75 is 150 minus 5. Or you can plug the 75 over here up at the corner spot there, and then you can add those 2 together. Though it'll be the same answer, so it's just up to you. Again, 5-1 through 5-3 feel like your answers are very numerical. There's a couple vocabulary here and there, but it's very numerical. Once you get to 5-5 for sure, then it's about half proofs, okay? So how are you feeling so far? Pretty good? All right. Do you know what a corollary is? Have you ever heard of that? What gets really challenging is we've got the definitions, postulates, theorems, and now we have corollaries. Remember, all of this goes back to how Euclid wrote everything down. So, a corollary. A corollary is something that comes from another theorem. So, sometimes we call it like easy, like it's an easy theorem from another theorem. Again, I didn't write your textbook, but I wish they would have put this one on today's lesson, because this is a corollary in a way. If you're equiangular, that means 180 divided by 3 is 60. Like, how else are you going to solve that type of problem? But they saved that one for tomorrow's lesson for whatever reason. So today's corollary is based off the triangle sum theorem. So the corollary literally says this. If you have a right triangle, so think in your head, triangle sum theorem, you have a right triangle. How much is left for these two angles? Okay, for the two, it's 90. They don't have to be 45 and 45. That's if it's isosceles right, okay? So if you have a right triangle, it doesn't matter how it's drawn, which way. If you have a right triangle, this could be 50 and this could be 40. You could have a right triangle, this could be 70 and this could be 20. I'm just making up easy numbers right now. I mean, we could go decimals and crazy numbers if you wanted. But what they're telling you is this corollary says that these two corners together have to total 90. So if you look at number 8, yes, I could go like this. Don't write this. 2x plus x minus 6 plus 90 is equal to 180. Yes, I could do that. But when I subtract off the 90, won't I get 90? So what they're telling you is instead of going through that whole process, that it would be faster just to add these two together and set it equal to 90. So 3x minus 6 is equal to 90. That it would be faster. I don't think any of you probably ran out of time yesterday on your PSAT. I didn't hear of any classrooms, but I heard lots of SAT people went right up to the borderline, and some of those teachers didn't get out on time because they were still collecting material at the very end and all that kind of stuff. So the SAT is many little tiny areas that you can gain a little bit of extra, minutes, seconds, whatever it is, will help you in the long run. So if you quick solve this, move the 6 over, divide, 32? Yes? Okay, then just make sure that's what they're asking you to find. Some of the questions in the homework ask you to find the variable, some of them ask you to find the angle, so just make sure you don't have to plug it back in. How are you feeling so far? Good? Okay, 9 and 10 are practically the same question. I'd almost rather do 9 than 10 just because 9 is a little bit more wordy, but if you want me to do both, but I was sort of just thinking we could do 10 and skip 9. Are you okay with that? Notice they both start out exactly the same. They're practically the same question. All right, so 10. In a right triangle, I'm kind of a visual person, so I just like to draw myself a triangle. So in a right triangle, the measure of one acute angle, so I'm just going to call it this one, this angle is twice the sum right? Twice the sum of the other angle. Do we know what this angle is? So let's call it x. So x, it's twice the sum of the other angle and 30. Now again, we could use triangle sum theorem, but if we use the corollary, we can just add these two together and set it equal to 90. And I don't have to finish this, let me just show you. X plus, now you might want to go ahead and distribute this out. So 2x plus 60, and then set it equal to 90. If you don't like that, you can add all of them together. So you could do plus 90 is equal to 180. you could use triangle sum theorem. But what they're saying is the corollary just maybe even makes the numbers a little smaller in case you don't have a calculator or something. So how do we feel with the first lesson of 5?